Hello my friends, this lecture is the last for this piping system course. Contents of this lecture, we will talk about piping stress analysis, what is the input and output data, program used in piping stress analysis, codes used in piping stress analysis. Number 2, piping supports and types of supports. Number 3, we'll talk about special consideration for piping. Number 4, we will talk piping designer input and output. In lecture number 3, we explained insulation of piping design table, piping calculations according to design code IPsys 31.1 for power piping, critical piping. What is piping stress analysis? Piping stress analysis, we have already seen that some of the pipes are subjected to high pressure and high temperature. Also, pipes carry the load of the flowing fluid. So we need to check and confirm the pipe isn't going to fail with this loading. This process of checking the stress developed in the piping due to various loading is called pipe stress analysis or flexibility analysis. In the process of analysis, we apply various postulated loading on the pipe and find out the stress resulted from this loading. Then we check with governing codes if those stresses generated are acceptable or not. If we work on power piping project, we will use code IPsys 31.1 for process piping, IPsys 31.3. Then we check support load movement for various loading conditions. So we also check out the terminal point loading generated from pipe to the equipment connected to the pipe. These loading are to be within acceptable limits of the equipment suggested by the vendors. We also find out the pipe growth due to change in temperature and need to keep the movement of pipe within acceptable limits. So the piping stress analysis is an interactive and iterative process. Each step is checked. If a check fails, we have to go back, modify the layout, and restart the analysis. Piping stress analysis. What is the inputs data must be considered when the designer make piping stress analysis. The input. Number 1, geometric layout of the pipe. Number 2, piping supporting configuration according to configuration of the supporting, and we will discuss types of support at the end of the video. Okay, pipe diameter and thickness, pressure inside the pipe, cold and hot temperature of the pipe, weight of pipe and insulation, weight of carrying fluid, pipe material property, Young's modulus, thermal expansion coefficient, thrust on pipe due to blowing wind, thrust on pipe due to earthquake. So wind and earthquake must be considered during stress analysis. Okay, load of snow on pipe, any transient loading like steam hammer load, any other load on the piping. Tools we use, programs, software programs used in piping stress analysis like IPsys. It is integrated pipe stress analysis module of Blades 2000. Caesar is a commercial piping analysis software, and also there are many other commercial program software to make stress analysis. What is the outputs? Outputs for stress analysis. Number 1, stress of the pipe at various loading condition. Number 2, load at various supports and restraints. Number 3, movement of the pipe at support locations. From this data we can get these outputs. Number four, pipe terminal point loading. What's codes in the standard? Codes as IPsys 1.1 for power piping, process piping as IPsys 1.3. IPsys is the analysis module of Plates 2000 program software for stress analysis. It is very powerful and flexible integrated stress analysis module. Work in this program in close interaction with BDWP, piping design workbench, piping model, to make 3D model for piping. Here are some of the screenshots from these programs. Okay, for IPsys and BDWP to make stress analysis. Now we will discuss types of supports, pipe support. The designer must know the type of support which he needs in piping, and he will make piping stress analysis according to it. Okay. In the beginning of the discussion, we talked about various types of pipe supports. Here is some elaboration. What are the types of supports? There are three general types. Number one, rigid type, no flexibility in the direction of restraint. Number two, spring type. Spring type allows pipe movement in direction of loading. Number three, dynamic support. Degree of restraint depends on acceleration fluid. Rigid type, spring type, dynamic support. Three types of support. There are two types of spring supports. Number one, variable load type, constant load type. What is the variable load? What is the constant load? From its name, variable load, support load changes as the pipe moves. When pipe movement, so the load changes. Constant load, it means the load remains constant within some range of movement. Now we see pictures for supports. This for constant load spring, this variable spring support. Constant, that the load constant during movement. Variable, support load changes during pipe movement. Okay. This rigid hanger support. Also we see rigid hanger support. This pipe supported by more than one type of support, as we see here. This is dynamic support. This is rigid support. Rigid support, that no flexibility in the direction of restraint. Here, rigid, no flexibility in the direction of restraint. Some typical pipe support drawings. Some typical pipe support drawings from vendor supplied for these supports. As we see in piping isometric drawing, each ISO contains support. Support number is defined in ISO with its number, so we can check it with piping support these details from isometric. We can get number of support. We'll check it with piping support drawing to know all data about these supports. What is here? Some pipe supports hardware details. This picture shows piping support configuration. These four spring supports. This picture. Some special considerations for piping. Special consideration for piping when pipes are routed underground. For underground piping, buried flowing points to be kept in mind. When used underground piping, you must take these points into consideration. Number 1, minimum pipe size to be routed underground shall be not less than 1 inch. Number 2, avoid flange joint in underground piping. Number 3, keep in mind if pipe leaks underground, it will be difficult to detect. So avoid underground routing of piping carrying hazardous fluid. Number 4, pipe to be laid down frost zone at areas where ambient temperature goes below freezing point. Number 5, underground buried piping should be properly protected from corrosion. Pipe may be properly wrapped and coated to prevent corrosion. Make coating or wrapping to prevent corrosion for underground piping, or protected by cathodic protection. Regarding freezing protection of outdoor piping, okay, for freezing protection, as you see here, pipe to be laid down frost zone at areas where ambient temperature goes below freezing. So in the areas where the ambient temperature goes below freezing, there is a possibility that the liquid content of pipe may freeze while the plant is under shutdown. What shall you do in this case? For similar case, pipes are wrapped with heat treating. You must use heat treating element. Why? To maintain the content temperature above freezing, around 4 degrees Celsius, even when the ambient temperature is below freezing. Electric heat treating is done by wrapping electrical coil. You make wrapping for the electrical coil around the pipe, which turns on as the ambient temperature goes down. Pipes are insulated over the heat treating coils. Heat treating can also be done by winding steam tubes around the main pipes. What is the piping designer's input and output? It is the last point in this course. Designer's input and output. Okay, what is the input of piping designer and output of piping designer? From process to process. From process, the designer must know what fluid, from where to where, pressure, temperature and flow rate, type of flow control. If he gets this information, the output, final pipe size and pressure class, piping system material. Regarding project, from project, what project specification, any existing facility or underground work. To project, the output is planned interface drawing, interface with existing facility. From mechanical to mechanical. From mechanical, he should know equipment locations and terminal parameters, so the pipe layout both above and underground, and equipment terminal loading. Okay, this is the output. From civil, he must know locations of foundations and structures, so the output is locations of pipe supporters, pipe support loading to foundation and structures, wall penetrations. From C&I, control and instrumentation, he must know types of control and instrumentation, tapping requirement. The output is location instrumentation. He can control the valves on piping isometric. From electrical, locations of electrical equipment, cable tray and bus ducts. So the output is pipe layout both above ground and underground to match cable duct bank outing. At the end of this course, I want to thank you for watching my videos and hope you have gathered enough knowledge to talk intelligently on the subject of piping and also start work on piping. Thank you. Goodbye.